Welcome back. This is the very first introductory video on the topic of concentrations. Now, this particular video serves two purposes. First, I'm going to just show you all the different concentration units. If you have had any basic level of science, you may have heard of molarity, but I'm not sure if you've heard the rest of the other concentrations. So I'm just going to show you a screenshot of all the different concentration units that you can use. Although I will not explain any one of those in great detail because we're going to look at each one of those separately in a video with a problem to go with it, so it just seems to make more sense. However, I think to show them all in one clean screenshot is just a great way to showcase them all, right? And the second purpose is I want to make sure that you can actually calculate number of moles, which was the focus of the previous topic. Now, if you can actually do that, then that's a problem because pretty much all concentration units require you 98% of the time to calculate moles. And if you can't do that, then that's a problem. Or you know how to calculate moles, but you have a problem converting chemical names to formulas, then you have to go to the topic on how to get formulas, the video I've given you, and watch that again. All right? And something else I want you to take away from this video, which is very foundational to science in general, is if you get out of my class and one of your friends asks you, or one of your relatives, family member, whoever, asks you what a solution is, and if you can't define it for them in a more simpler sense, you've just wasted your time in my class, and that's a real crying shame. All right? So let's actually define what a solution is, because that's very important. A solution is a combination of two things, a solute and a solvent. Typically, your solute is always, I don't know of a situation, it's usually less in quantity, and your solvent is always going to be the major portion of your solution. Okay? Typically, solvent is water. If you're trying to make, salt solution, you're going to add sodium chloride plus water. Okay? This is your solute. Usually, your chemical substance is your solute. And solvent could be water, alcohol, anything that's usually in large proportion. But typically, solvent is used as a water, provided your substance is polar. If it's non-polar, then you would use maybe, I don't know, something like hexane, propane, whatever be it. So this is a solution that results you in a salt solution. And that's the meaning of a solution. So don't forget these two terms, solute and solvent, and solution, because if you get them mixed up, then you're going to have a lot more trouble actually taking a problem that is simple and making it more complicated. All right, so here's all the concentration units. Molarity is moles of solute over volume of solution in liters. Pay attention, solution, and this is the unit. Molality, moles of solute over volume of solvent in kilogram, and that's the unit. It's very important that you know the units because this is easy. The only way you're going to make it complicated is you just want to make it complicated. Mass percent, there's multiple different ways this is used. It's basically mass of one component. Say you have 10 different components. You add the mass of all the components, that's the total mass of the component, and you take mass of one component and divide by the total mass, that's mass percent. But there's also other ways to do this. We're going to see that in action when we get to that. Mole fraction. That's again, it's like mass. If you have 10 different things, if you calculate the moles for each one, add all the moles, that's the total number of moles, and the mole of each component by the total moles will give you, this should be not moles over kilogram, that's from copying and paste. Mole fraction actually does not have a unit. It's unitless. Okay? So that's mole fraction. All right, and then I'm going to have you pause the video once you see the choices and see if you can get the right answer, and then continue watching the video. So I'm going to work it out, assuming you have paused now. And so manganese 4 chloride, the 4 stays with manganese, so it's 4, and manganese is a metal, so it's plus. Chlorine is actually 7A, and it's 8 minus 7 is 1, and it's a non-metal. So we swap, and we get MnCl4 as our formulae. Now, how do we go from grams to moles? If you remember that little chart I gave you, you have to go through molar mass. That's the only way. So let's go get the molar mass of this MnCl4, and I've already calculated that. It is 195 grams over mole. Remember, I told you don't write it this way, 195 grams over 1 mole. So we want to go from grams to moles, so we put a block and put the given information at the very top here. Put a 1 because there's nothing on the bottom. We got to get rid of grams, we want moles, so we put the 195 grams on the bottom, the 1 mole on the top, and then we can actually get the answer, and that'll be 0.0128 moles. This is how you calculate moles anytime you are given grams. Good. Got one more question for you, just like the same thing, but sometimes 2 is better than 1. So same thing. So I'm asking you to calculate how many moles present in 0.75 grams of manganese 4 phosphide. So your first job is to figure out the formulae. And so manganese is Mn, and the 4 goes with the manganese, and manganese is a metal, so it's plus. Phosphorus is 5A, so it's 8 minus 5 is 3, and it's a non-metal. And we swap, we get Mn3P4. And if you get, again, we're going from grams to moles, so we have to go through molar mass as our liaison. So molar mass of this Mn3P4 is roughly about 289 grams over 1 mole. So as always, draw a block, put your given information, which is 0.75 grams on the very first column, put a 1, and then 289 grams goes on the bottom. Why? Because we want to get rid of grams when we want our answer in moles. So it's like a chameleon. You switch the numbers based on your need. And if you do that, it'll be 0.0026 moles. And that's the answer. So what I really wanted to get across through this video is just to summarize the same concept we learned previously. But again, giving it as a quiz means you would tend to have that competitive edge in you and pause the video and actually work it out, and then continue watching the video to figure out the answer. So you must know how to get moles, which means there's 2 things. One is this right here, being able to calculate the formulae. This is an important step, okay? And then this right here is an important step. So I'm going to put a star next to it to tell you that if you can't get the formulae, or you don't know how to go from grams to moles, then you would never be actually able to get the concentration calculated. Again, we have not learned actual concentration concepts yet, but this is the foundational video which would allow us to get started as we head into the direction of calculating concentration. So stay tuned for those videos.